Welcome to Informatica Cloud 201 on-demand course, Performance and Scalability. Upon completion of this module, you will be able to understand push-down optimization and why it is used, discuss ETL and ELT, discuss guidelines and best practices for push-down optimization, and understand recovery and its types. Let us now understand what is push-down optimization. The push-down optimization or PDO is a feature in which a mapping can be converted into a SQL code and executed on the database. Hence, this process generates database-specific SQL based on the mapping logic and sends processing to database as applicable and needed. This process is useful when we deal with huge volumes of data from the source. Sometimes, instead of reading all the data to the Informatica Cloud server, it might be useful to do some of the transformations such as filtering, aggregation, joining on the database itself, and then write the final output to the target. There are two types of push-down optimization processes. Full PDO, where all the mapping logic is converted to SQL and sent to the database. We will focus on this type of optimization in our module. Partial PDO. In this type of PDO, a portion of mapping logic is converted to SQL and executed on the database, which could be either the source or the target. Let us now understand why do we need push-down optimization. The push-down optimization helps address scalability and performance problems encountered by the customers with very large data sets from the data warehouses or databases like Redshift, Oracle, or MS SQL, etc. It provides flexibility to push down transformation processing to the most appropriate processing source, whether the source, target, or the Informatica Cloud server. This can significantly improve performance and reduce data movement across the network. It can also leverage the power of the database server hardware, which may be significantly more powerful than the ICS Secure Agent hardware. With this option, the ICS solution architects can select the database and push the transformation logic partially or completely to the database in any one of the three ways: full pushdown optimization, partial pushdown optimization to the source, or partial pushdown optimization to the target. Before we get into details of understanding how pushdown optimization works, let us discuss what are the various approaches of the data integration process. As you know, data integration is the process of combining data from many different sources into an application. You need to deliver the right data in the right format at the right time frame to fuel great analytics and business processes. There are three main approaches. ETL approach. It extracts from the sources, transforms inside ICS Secure Agent, and loads into the target tables in the data warehouse. The ELT approach. It extracts from the source systems, loads into the staging tables inside the data warehouse RDBMS servers, and transforms inside the RDBMS engine using generated SQL with a final insert into the target tables in the data warehouse. There is also a combination of ETL and ELT approach known as a hybrid ETLT approach. It consists of 4 steps. Extract from the source systems, transform inside ICS Secure Agent, load into the staging tables in the data warehouse, and transform inside the RDBMS engine using generated SQL with a final insert into the target tables in the data warehouse. Now that we already have discussed a gist of combination ETL-ELT approach, let us now discuss the same in more details. Initially, Informatica Cloud communicates with the ICS Secure agent and passes both ETL and ELT instructions to it. With the help of these instructions, the secure agent extracts the data from the required source and processes it according to the ETL instructions provided. The secure agent then loads the transformed data to a target database, say Oracle. Informatica Cloud then passes the ELT instructions to the secure agent, due to which the secure agent extracts data again from the defined source, generates some SQL commands, and loads them to a target staging table in the database. In the staging table, the transformation of the data takes place by the execution of the SQL commands. This is how we can get the best of both the worlds. Let us now compare the ETL and ELT approach based on different situations. In some cases, ETL seems to be a better approach as compared to ELT. When data sources and targets are heterogeneous or transformations are not well suited to set-based processing, ETL is a better approach as compared to ELT. Also, if there is a situation when message-based fields have real-time data acquisition or transformations and tools that are not convertible to SQL, ETL is the only approach. The ELT approach does not work in such cases. Also, if the transformations are multi-step that do not require access to large volumes of historical or lookup data, ETL is a better solution. Now, under the following situations, ELT processes run successfully, however, the ETL processes have restrictions or do not get executed at all. Leverage database processing capacity during off-peak hours. Transformations that require access to historical data or require access to very large lookups within the database. Large datasets with small or minimal transformation requirements. Optimized performance for large datasets which are well suited for set operations, for example, complex joins, aggregations, etc. Let us now discuss few important points you need to remember regarding the pushdown optimization. The pushdown optimization improves performance of data integration and transformation tasks. However, PDO is neither a replacement for scripting nor a replacement for ETL. PDO is not the only way to send processing data into the database. Other methods such as SQL transformation, pre- or post-session SQL scripts can also be used to achieve the same task. Whether or not PDO is used, the output of the mapping is the same regardless of where it is executed. The PDO mapping design will likely have design considerations different from typical ICS mapping design, so that works in ICS mapping may not work in the database. Let us now discuss certain pushdown optimization usage guidelines. Full PDO is used when all data sources and targets exist in the same database server. The most common use case for full PDO is data warehouse staging to target loads. In the mapping shown here, you extract the data, sort and aggregate it, and then load it to the target. In the normal execution, the data can be selected from T1, which is a relational table in schema U1, and will be loaded to table T2, which might or might not be in the same schema. So looking at the statement, we could never make out in which schema T2 belongs to. However, when you use PDO, the data is selected from table T1 in schema U1 and inserted into table T2, which is in a different schema named as U2. So here, PDO automatically adds appropriate qualifiers for database transactions to execute properly. PDO may be most optimal if runtime is dominated by data volume out of and into data warehouse. So, PDO can be used in situations when you require to access large volumes of historical data. Let us consider a situation where total amount of data in a table called orders is equal to 100 GB. If such a huge amount of data is read from the source, the data reader of the secure agent fully engages the system in this process. Once the data is read, transformation of data utilizes the space by acquiring the memory caches and utilizing the RAM to a great extent. Then, the writer comes into the picture, which loads the data to the target. Again, to load such a huge amount of data, the system becomes engaged in this process, failing other processes. In such a situation, usage of PDO may be the most optimal. If substantial amount of data can be reduced using transformations like filters, aggregations, and joiners, PDO may be the most optimal implementation. For example, if total amount of data in a table, say, lintim equals to 100 GB, total amount of input rows processed by ICS mapping equals to 600 million. Let's say that the total amount of input rows processed by pushdown after filtering is 70 million. In such a case, PDO may be the most optimal implementation. PDO may be the most optimal in cases where updated statistics results in better performance. Let us consider filter condition provided at runtime results in a higher volume of rows from different tables at different times. In such cases, database may be able to choose the best master detail combination at runtime based on the updated statistics, and this may result in better joiner performance. Next, let us discuss how data integration or DI to database or DB function conversions happen when pushdown optimization is used. Functions available in DI and DB differs. PDO may or may not be possible depending on this. Note, PDO will make the appropriate DI to DB function conversion wherever possible. However, you must check the list of functions that are supported for your database. For example, to convert an integer into a string and pad the string with leading zeros, in ICS, you can use an lpad function such as add 0 to the intval field after converting it into character type to make it of a uniform length consisting of 5 characters. In DB, there may not be an equivalent lpad function. If the processing can be represented in functions that are available in DB and DI, you can modify the mapping to push it down. In the example, if equivalent lpad function is not available, then you can use the substr to obtain the same results. If not, use DI to do the processing. One more important guideline to be considered in PDO usage is PDO SQL. The PDO SQL is the functional equivalence of the ICS mapping. Depending on the semantics of the data, it may be required to design the ICS mapping differently to get better PDO results. The PDO SQL generates a subquery for lookup intentionally in order to retain the same session behavior as that of ICS, which returns one row for a lookup match. If your data semantics allow a joiner, replace lookup with a joiner transformation. Let us now discuss the pushdown compatible connections. It is possible in a single PDO session that we can have multiple connection objects. However, when you run a pushdown optimization session which involves multiple connection objects, only one of the connection is chosen as an active connection. This connection, otherwise called as the user, is used for executing the pushdown SQL. The other connection objects will not be used. Because one user will be used for accessing all the tables, you need to ensure that the particular user has appropriate database permissions to access rest of the tables. The connection or the user which is chosen will be based on a predetermined criteria. To configure the full pushdown optimization, if the source and target reside in separate databases, enable the flag Allow Pushdown for user incompatible connections in the session properties. This also indicates that the database user of the active database has read permission on idle databases. As we discussed earlier, that if PDO session involves multiple database connections, only one connection can be considered active and the other are idle connections. So far, we have discussed usefulness of PDO usage. Let us now discuss what are certain considerations and limitations of PDO. When you run a task with large quantities of data and full pushdown optimization, the database server must run a long transaction. Consider the following database performance issues when you generate a long transaction. A long transaction uses more database resources. A long transaction locks the database for longer periods of time, which can reduce database concurrency and increase the likelihood of deadlock. A long transaction increases the likelihood of an unexpected event. To minimize the database performance issues for long transactions, consider using source or target pushdown optimization instead of a full pushdown optimization. The SQL for update could be expensive to execute if the target table is a lot larger than the source or if the target has many non-key columns. As an example, this could be due to each non-key column generating a subquery that returns a value to be assigned to each non-key column. Let us now discuss the considerations and limitations for lookup and unconnected lookup transformations. Let us start with lookup filters. The pushdown optimization process stops when the lookup transformation returns multiple matches. This is because PDO cannot be configured to return multiple matches. Another important point to remember that PDO needs privileges in the database to create temporary views. This is because Informatica Cloud Service creates a temporary view in the database while pushing a lookup transformation to the database. Let us now discuss the limitations of PDOs for unconnected lookups. Similar to lookup transformations, pushdown optimization process stops when the unconnected lookup transformation returns multiple matches. The PDO process does not work with unconnected lookups with target partial pushdown. As with lookup transformations, for unconnected lookups, PDO needs privileges in the database to create temporary views. Let us now discuss what considerations do we need to make when pushing functions to a database that contains date fields. Prior to Informatica version 8.5, functions such as toDate and toChar can be pushed down only if they did not contain any optional parameter. However, from version 8.5 onwards, toDate and toChar can take an optional date format parameter. However, the translation from DI to DB functions are sometimes required. For example, YYYY MMDDHH 24 MISS. It needs to be converted to Y4 MMDDBHH MISS on Teradata. Problem can still arise if the date format is not supported by the underlying database. Informatica has tried to detect unsupported formats and fix them, however, has not been able to solve all of the issues so far. For example, 6/1/2007 fails for MMDDYYYY format on Teradata as Teradata expects the date to be in 06/01/2007 format. The execution of the generated SQL statement can fail if the underlying database does not support the date format. Let us now discuss how error handling and logging is handled when pushdown optimization is enabled. Some functionalities available in DI may not be available in DB processing, so you need to choose the PDO according to your requirements. When PDO is enabled, the database executes the SQL. If any error occurs, the database handles the errors. So it is not possible to make use of ICS error handling feature like error files. If we configure a session for full pushdown optimization and the session fails, ICS cannot perform incremental recovery because the database processes the transformations. Instead, the database rolls back the transactions. If the database server fails, it rolls back transactions when it restarts. If the ICS fails, the database server rolls back the transaction. For logging, ICS does not get the same level of information about the transformation process information in the log because the transformations are processed in the database. A direct collaboration of Informatica and Teradata resulted in creation of the PDO. Let us now discuss some best practices for best utilization of PDO. Try to avoid unconnected lookups whenever possible and lookups on parallel paths in mappings that would benefit from PDO. The best solution would be to create sequential lookups. Eliminate sorted aggregation and pass-through ports in aggregators and variable ports. It's better to use full pushdown optimization because of large data volumes. Best performance can be obtained by doing all processing inside the database. Do not forget about the database query tuning. Few other points to remember are: avoid full table scans for large tables. Use staging processing if necessary. Use temporary tables if necessary. Validate use of primary and secondary indexes. Some more best practices to consider are: you should minimize use of non-PDO convertible transformations and functions, since this will prevent the transformation logic from being completed pushed to the database without using a SQL override. Understand the limitations with your database technologies such as Redshift, Oracle, etc., and the limitations in the use of transformations. You need to also understand string to date timed conversions in your database using the cast function. This is useful in override SQL. Let us now discuss the recovery strategies in ICS when a workflow with PDO process fails. There could be several reasons when a workflow fails. For example, services could shut down unexpectedly, network failure might occur, or some processes were disabled accidentally when the workflow was running. One strategy you could use is that when something fails in the workflow, then suspend the workflow. Another strategy could be to design the processes to be easily recoverable. There are 3 types of recovery strategies that we should utilize when developing with ICS. Basic restart process. Restart the process when something fails in the workflow. Delete then reload. Process requires partially loaded data to be deleted before recovery. This means while the workflow was loading data to a target and the process fails in the middle, the partially loaded data has to be deleted. Truncate the reload process. You need to perform this only if you require a full refresh your system that stores data. Process performs a truncate before restarting, which all the data in the table are removed before the process is restarted. Let us discuss the basic restart recovery process. The basic restart process is designed to have no intervention and can be automatically restarted with no dependencies. All full pushdown optimization processes are restart processes. Data is only committed if all data is successfully loaded. Otherwise, the data is rolled back. An example would be a mapping that is leveraging full pushdown. The reason is that the data is either committed or not committed. No partial data loads take place. So initially, we extract data. If there is some error in extraction, the process is repeated. If not, then transformation of the data takes place. If the transformation fails, the process is restarted. Otherwise, the transformed data is loaded in the target. If the loading process fails, then the whole process is restarted. Otherwise, the next process is started. Let us now talk about delete then reload. Delete then reload design approach is used when a mapping can by chance have a partial commit before an unexpected error occurs. If part of the data can be loaded and the process is not easily designed to account for that data, that is, being a state-aware process, this pattern should be implemented. In delete then reload, if any error occurs in the extraction and transformation process, the process again starts from extraction of the data. However, if the load process fails, then delete partial data load task starts. If the deletion process is unsuccessful, then the process is restarted. If successful, then next process can be started. The third type of recovery process is known as truncate reload. This process is easy to recover. All data is reloaded, so rerunning the process does not require much implementation or consideration. This usually occurs during the Teradata data acquisition phase. Initially, the data is truncated. If this task fails, then it is restarted. Otherwise, ETL process starts, which was explained earlier. Here, each time any task fails, the data is truncated and the process is restarted from the initial point. In this demo, we will demonstrate how to create an MCT with full pushdown optimization enabled and populate a table in Oracle database. Consider you are the senior ETL developer in your organization and you need to update some child tables in the database as and when the parent tables are updated. The source and target tables are in the same database. In order to accomplish this task, you create a mapping configuration task with full pushdown optimization enabled. When you do so, the Informatica Cloud Service translates the transformation logic into SQL queries and sends the SQL queries to the source or the target database, which executes the SQL queries to process the transformations. The amount of transformation logic one can push to the database depends on the database, transformation logic, and mapping and session configuration. To perform this demonstration, we need to access the Oracle database. We can use the Oracle version 11G or 12C. We have already downloaded and installed Oracle 11G on the system. I have created a new connection called HR with the details as shown here. I have also run the DDL scripts to create 3 tables: Act Customers, Act Orders, and Act Order Summary. Next, we need to create a new connection for Oracle in Informatica Cloud org. To do so, let us log in to the Informatica Cloud org. Hover over Configure, select Connections, click New to create a new connection. Type ICS Oracle Connection Demo as the name of the connection. Select Oracle from the Type drop-down. Now select the runtime environment. Type the database connection's username, password, host, port, service name, and code page values. Click Test to test the connection. Click OK to save the connection. The data to populate the ACT orders and ACT customers tables are provided in the ACT orders CSV and ACT customers CSV files respectively. We will create the DSS tasks to load the data from the files to the database tables. Create a DSS task to load data from ACT Customers CSV file to ACT Customers table in the Oracle database. Hover over Task Wizards and select Data Synchronization. Click New to create a new DSS task. Type Customer Oracle Insert Demo in the name field and select Insert from the Task Operation drop-down. Click Next. To set up the source, select your existing flat file connection from the Connection drop-down. Select Single from the Source Type drop-down. Click the Select button next to the Source Object drop-down. From the pop-up window, select ACT Customers CSV Radio button and click Select. Click Next. To set up the target, select your newly created Oracle connection from the Connection drop-down. Click the Select button besides the Target Object drop-down. From the pop-up window, choose ACT Customers and click Select. Change the Truncate Target option from False to True. Click the Field Mapping button. Now click the Auto Match button to automatically match the fields. And then, from the Save drop-down, select Save and Run. Check that the task ran successfully from the Activity Monitor. Also notice that the database table ACT Customers is populated with data. Similarly, we have to create a DSS task to populate the ACT Orders table. ACT Customer Order Summary being the target table should be blank. Now we are ready to create a mapping configuration task with full pushdown optimization enabled. We will start with creating a mapping. To create a mapping, hover on the Design tab and click Mappings. Click the New Mapping button. In the New Mapping window, enter the name of the mapping as Mapping with Pushdown Optimization Demo and give a suitable description if required. Click OK. The mapping now appears on the canvas. Now add a source to the mapping. Drag and drop the source shape onto the canvas. In the Source Properties pane, enter the source customers in the name field. Click the Source tab in the Source Properties pane. Select the Oracle connection created previously from the Connection drop-down and Single from the Source Type drop-down. Click the Select button beside the Object text box. From the pop-up window, select ACT Customers and click OK. Click the Fields tab. Select the Edit Metadata checkbox and Customer ID checkbox. Click the Native Type entry and select Varchar from the drop-down. Uncheck the Edit Metadata checkbox. Add another source to the mapping. Drag and drop the source shape onto the canvas. In the Source Properties pane, enter Source Orders in the name field. Click the Source tab in the Source Properties pane. Select the Oracle connection created previously from the Connection drop-down and Single from the Source Type drop-down. Click the Select button next to the Object text box. From the pop-up window, select ACT Orders and click OK. Click the Fields tab. Click the Edit Metadata checkbox and then the Customer ID checkbox. Click the value of Native Type column. Choose Varchar from the drop-down. Uncheck the Edit Metadata checkbox. The native type of Customer ID is of the type string. Since we will specify a join condition based on the Customer ID of the Customers table and that of the Orders table, we have ensured that their data types are same and hence their values can now be compared. Now let us add a joiner transformation. We will specify a simple join condition by comparing the customer ID values of both customers and orders table. If customer's customer ID is equal to order's customer ID, then only those records will be filtered and written to the target. Drag and drop the joiner transformation shape into the canvas. Link source customers to the master of the joiner transformation and source orders to detail of the joiner transformation. Select the joiner transformation. In the General tab of the Joiner Transformation Properties pane, type JNR_customer. In the Name field, click the Incoming Fields tab. A message saying there are name conflicts in the incoming fields is displayed since both the tables have Customer ID field displayed. To resolve this, click the row below Field Rules for the master. Select Include from the master drop-down columns and Named field from the Field Selection Criteria column. Click Configure under the Detail column. In the pop-up window, click the Field Name checkbox to select all the fields and then click Rename Selected tab. Select the Bulk Radio button and Prefix from Bulk Rename Options drop-down. Type cust_ for the column names of the Act Customers table in the specified text box. Click OK. Repeat the same steps to add a prefix to all the column names of the Act Orders table. Click the Join Condition tab in the Joiner Properties pane. Select Normal as join type and Simple from Join Condition drop-down. Click the plus sign in the Join Conditions pane. From the Master drop-down, select Cust Customer ID and Order Customer ID from the Detail drop-down. Click the Advanced tab in the Junior Customer Order Properties pane and check all the advanced settings. Next, we will add a sorter transformation to the mapping so that we can sort the data before we can input to the aggregator transformation in the next step. Drag and drop the sorter transformation shape onto the canvas. Link the joiner transformation to the sorter transformation. Click the General tab in the New Sorter Properties pane. Type Sort Customer in the Name field. Click the Incoming Fields tab. We won't require all the incoming fields, however, Cust Customer ID, Order Line Total, and Order Units Sold. So, we will keep these three fields in the Incoming Fields list and remove all others. Click the row below the Operator column to select Include option. Select Named fields from the Field Selection Criteria drop-down. Click Configure to configure the incoming field to be included. From the pop-up window, select the Cust Customer ID, Order Line Total, and Order Units Sold checkboxes. Click OK. Click the Sort tab. Click the plus sign beside Sort Conditions. Select Cust Customer ID from the field drop-down and Ascending from the Sort Order drop-down. Click the Advanced tab. Check all the settings are done as per the requirement. Now add an aggregator transformation. To do so, drag and drop the aggregator shape to the mapping. Link the sorter transformation to the aggregator transformation. Click the General tab of the New Aggregator Properties pane. Type and meaningful name in the Name field. Click the Incoming Fields tab. Check that only 3 fields of the sorter transformation appear as the incoming fields of the aggregator transformation. Click the Group By tab. Click the plus sign next to the Group By fields. From the Field Name drop-down, select Cust Customer ID. Click the Aggregate tab. Click the icon above the Actions column and from the pop-up, select New Field. In the pop-up window, select the output field from the Field Type drop-down. Type Aggregator Total Sold USD as name of the field. Select String from the Type drop-down and 10 as Precision. Click OK. Click Configure below Expression column. In the pop-up window, in the Expression text area, type the following expression: sum order line total and click OK. Follow the same steps to create a new output field, Aggregate Total Units Sold USD, with an expression sum ord units sold. Click the Advanced tab. Click the Sorted Input checkbox. Set parameter to acknowledge that the input to the aggregator has already been sorted. Finally, let us add a target to the mapping. Drag and drop the target shape onto the canvas. Link the aggregator transformation to the target. Click the General tab of the Target Properties pane and type Target Customer Order as the name of the target. Click the Incoming Fields tab. Add Order Line Total and Order Units Sold fields as excluded fields. Click the plus sign above Actions column in the Field Rules. Select Include from the Operator drop-down. Named fields under Field Selection Criteria and click Configure. In the pop-up window, select fields Aggregate Total Sold USD, Aggregate Total Units Sold, and Customer ID. Click OK. Follow the same steps as above to exclude two fields, Order Line Total and Order Units Sold, from the incoming fields. Click the Target tab. Select the Oracle connection, same as the source, from the Connection drop-down. Select Single Object as target type. Click the Select button next to the Object text box. From the pop-up window, select Act Customer Order Summary and click OK. Click Insert from the Operation drop-down. Also check the Truncate Target checkbox. Click the Field Mapping tab. Drag Customer ID besides Customer ID, Aggregate Total Sold USD besides Total Sold USD, and Aggregate Total Units Sold besides Total Units Sold in Map Fields column. Save and deploy the mapping to a mapping configuration task. Click the Save and New Mapping Configuration task to validate and deploy the mapping to a mapping configuration task. In the New Mapping Configuration task screen, type PD Optim Config Demo in the name field. Select your Active Secure Agent from the Runtime Environment drop-down. Click Next. Scroll down the page to Advanced Session Properties and click Add. Select the Push Time Optimization from Session Property Name drop-down. Select Full from Session Property Value drop-down. Note: if we create a mapping configuration task, we can set the Push Time Optimization. We can set the Pushdown Optimization Advanced Session Property to Full. When the MCT is executed, the mapping is translated to SQL and the SQL is sent to the connection to perform the transformation defined in the mapping. Click Save and Run to validate and run the MCT. We can view the task status in the activity log. As you can see that task got executed successfully with 0 error rows. Open the MCT by clicking the task name. Click the link View Session Log. As you can see, a SQL query was executed to populate the data in the database. To view the query that was executed, check the session log text file. Check the Act Customer Order Summary table. The table should now be populated with data. This concludes the full pushdown optimization demonstration. You're now ready to perform a lab. In this lab, you will create a mapping with same source and target connections, create a mapping configuration task with full pushdown optimization enabled, and check that the target was populated using a database query. There is an independent investment firm that provides innovative private equity solutions to institutional clients worldwide. As one of the first private equity fund of funds, they have a long and distinguished history of investing in ventures, buyouts, mezzanine and distressed markets through primary partnerships, secondary purchases, and direct investments. The organization needed to provide sales teams worldwide a single, shared view of client relationships, including contact information, investment history, and recent activity. They wanted to shrink the Salesforce.com integration time to weeks, thereby enabling the organization's client relationship managers to become more productive. They also wanted to ensure that they communicate with clients with one voice through their chosen communication channel and support the company's rigorous compliance and data privacy strategy. To achieve the business needs discussed above, they wanted to synchronize back-office investor client information with Salesforce.com sales management system, support querying across multiple Salesforce.com objects, deliver automated scheduling of jobs that integrate over 25,000 rows of data between systems per day. However, with the applications and processes they used, addressing these above-mentioned requirements was very tedious and involved many complex steps and processes. Moreover, the turnaround time of the solution was in months. Informatica Cloud's pushdown optimization feature enabled the organization to synchronize and update more than 250,000 rows using the combination of ETL and ELT processes. This enabled them to increase sales effectiveness and business efficiency immediately. It also ensured that sales teams delivered cohesive and compelling sales messages for improved client retention. It increased knowledge, their sharing and communications across the global organization. ICS supported the stringent market regulations regarding compliance and data privacy and introduced up-to-the-minute multi-channel client view. Finally, the organization was able to provide fast, low-risk routes to increase their sales effectiveness and responsiveness. This concludes the pushdown optimization module. In summary, we understood the pushdown optimization and why it is used, discussed ETL and ELT, discussed guidelines and best practices for pushdown optimization, and understood recovery and its types.